In one stroke, Professor Klaus Schwab, founder and head of the World Economic Forum in Davos, Switzerland, put end blindness by 2020 near the top of the world's to-do list by placing it on the agenda of the World Economic Forum.
This is a session called A Journey of Discovery, Ending Blindness by 2020 Initiative. I'm Al Somer, and I'm an ophthalmologist and an epidemiologist by training, and I've spent most of my career trying to, in fact, prevent blindness. And my colleague in crime today is Josh Sains.
Hi, pleasure to be here. I'm a biologist at Harvard University, and I'm the director of the Center for Brain Science there. That center deals in what's called systems neuroscience, which is figuring out how the circuits of nerve cells in the brain work together to underlie all of our mental activities like behavior, thinking, and most relevant today, perception. My own work is on how those circuits develop during embryonic development and early postnatal life, particularly in the visual system, and that's really what accounts for my being here. I'm a basic scientist, I should say. I'm not a MD like Al is, but my basic research for many years has been on the visual system and the circuits that allow us to see. So to get started, Al, who's been in this field far longer than I have, maybe you could tell us a little bit about what EB 2020 is and what the state of visual health is in the world today.
EB 2020, which is the brainchild of a wonderful gentleman, Sandy Greenberg, who went blind from glaucoma very uncharacteristically while he was a freshman or sophomore in college. That didn't stop this very determined individual from going on and getting a Harvard Law degree, having a visiting scholarship overseas, working in the White House, and being a successful businessman. And he's now become passionate about restoring vision to people who have been blinded. The major causes of this incurable, if you will, blindness at this time are macular degeneration, diabetic retinopathy, and glaucoma. And what those three diseases do is destroy either the retina, the fine lining in the back of the eye, or the optic nerve that carries the message of the visual impulse to the brain. We can't do much about restoring a retina at this point or restoring an optic nerve at this point. So Sandy has focused this EB 2020 on trying to stimulate basic science of the kind that Josh and others do, and he will talk about, into coming up with discoveries in the laboratory, and some that already exist, that can be transferred into available therapeutic interventions. So let me turn it over now to Josh to talk about those.
Okay, so what we thought we'd do now is talk about what may be at the heart of EB 2020, which is a whole new revolution in high-tech approaches to restoring vision to people who've lost it. So what I'm going to do is sort of in 1 minute each run through what I think are 6 signs of great hope. The first one is already in the clinic, and that is the fruit of the recombinant DNA revolution, which is now about, I would say, 20 to 30 years old. And that's the use of a compound called VEGF that can now be made in recombinant form, injected intraocularly, and is remarkably effective in halting the progression of age-related macular degeneration of a particular type called wet macular degeneration. Another one that just entered the clinic is very, very high-tech. That's the use of visual prostheses. And the idea is you have a very tiny little TV camera mounted on your glasses, kind of like Google glasses, and then that feeds a signal to a receiver that's outside your eye that sends an electrical signal actually into your eye, where it stimulates a set of electrodes that essentially provide electrical stimulation to the processing units I mentioned in cases where the pixels themselves have been destroyed by a disease like macular degeneration or retinitis pigmentosa. So a third method that is also being used to essentially replace pixels that have been damaged comes from amazing recent progress in stem cells. And probably everybody here has heard about stem cells. You may know that now they can be taken either from embryos or even from a person's own tissue. And there's everyday improving protocols in turning those stem cells into any cell you might want. And there, the first clinical trials are underway, in which a company in California has injected into a very small number of people with macular degeneration cells that have been transformed in a dish into what are called pigment epithelial cells, which are essentially the backing on which the pixels live. And it's really those cells that are early, are lost early in the course of macular degeneration. Another method uses gene therapy. So stem cells are increasingly being thought of as vehicles for gene therapy, in which you would, say, take a cell from a person who has a mutation that renders them blind, and as I already said, try to replace that gene and then amplify the cells and put them back in. Another approach is to use viral vectors to insert the gene into the sick cells before they die, before they get too sick, or if it's a case where those cells don't die, to insert the gene and restore vision. The fifth one is sort of otherworldly. It makes use of a invention, now a field, I would say, that transformed neuroscience less than 10 years ago. It's called optogenetics. I don't know if people here, Tom Insel has definitely heard of this, and is busily involved in supporting it. So this actually, it's really amazing. So it uses a protein that actually comes from a bacteria, and that protein, like the pigments in your photoreceptors, convert light energy into electrical energy. Okay, so that's the first step that a pixel does in your camera, and that's what your photoreceptors do in your eye. In cases where your photoreceptors are gone, like in macular degeneration, what people are thinking about is taking this artificial light-activated pigment, a light-activated molecule that generates electricity, and putting it into the cells that remain. You're not trying to get back the photoreceptors, but you're making light sensitive the next step. So you lose some of the information processing capability, but it offers the hope of restoring vision with really quite remarkably good acuity. And this is already being done in experimental animals, and certainly there are trials planned, but to the best of my knowledge, it hasn't been done in people yet. So sixth and last, I want to mention something that I think is going to be really essential in the long run, and it's not restoring vision, but it's diagnosing visual disability at an early stage. Because I think what everybody wants to do is prevent vision loss, and to do that, you have to be able to detect signs of visual loss in people before they know that their vision is being disabled. And so there are phenomenal new technologies that are making that possible. There's something called OCT, which is already in the clinic, and the next generation called laser ophthalmoscopy is nearing clinical use. And this allows people to look into the eye and actually see one by one the cells at the back of the eye, to count them and to detect the earliest signs of cell loss in diseases like macular degeneration or retinitis pigmentosa or glaucoma. And so I think in the long run, these diagnostic improvements coupled with all the restorative improvements are going to be what will allow us to restore vision in 2020.
Great, thanks. Let me just put one subtle, as an ophthalmologist, perspective on this. Whereas our friend Sandy Greenberg would like something that actually will restore perfect 20/20 vision, like most of us in this room possess, In fact, taking somebody who is black blind and giving them the opportunity to just detect light, the direction that light is coming from, can have an amazing impact on their functioning. Because they can tell where a window is, they can tell where a door is. That alone, when we do sort of a cognitive and social testing of people, makes a big difference. But of course, you want to also be able to see better than that so that you can carry out your regular jobs without the need of special assistance and so forth. All right, great. Thank you all for joining us.
Good afternoon, everybody. Thank you so much for coming today. My name is Susan Goldberg. I'm the editor-in-chief of National Geographic magazine, and I'm very honored to be here today to moderate this panel of the world's most preeminent experts on blindness. This panel is framed around the question of, can we end or prevent blindness by 2020? Let's look at what's being done, what are the promising pathways, and is there a road that we're on in terms of reversing or even ending blindness? So let me briefly introduce our panel here. Starting at my left, Josh Sains is the director of the Center for Brain Science at Harvard, and he does basic research on the billions of neurons that connect with each other in the brain. Next to him, Graziella Pellegrini. Stem cell advances are revolutionizing the field of regenerative medicine, and that's a field in which Graziella is a distinguished pioneer. Next to her, Al Sommer. He has won every award imaginable in the last 40 years, and he's now Dean Emeritus at the Bloomberg School of Public Health at Johns Hopkins University. And last but certainly not least, David Cox. David is a neuroscientist and computer scientist at Harvard who's studying the brain and trying to replicate vision in machines. So very cutting edge work. So thank you all for being here today. Like I said, I'm honored to be in your presence. Let me start with a very kind of 30,000 foot question. And Al, why don't I start with you? So preventing blindness or restoring vision, where are we making more progress and why?
Well, I think we're making progress in both areas. My work is primarily, at this stage, working with people and looking at the issues of why we can't prevent those things that we already know how to prevent. 2 or 3 of the major causes of blindness that we can now prevent and do largely prevent are the xerophthalmia that you mentioned, the work that I did, trachoma and onchocerciasis, and that's why 90% of all the blindness is in the developing world, because they are not receiving the preventive services that we know how to provide, but simply don't have the resources and the trained person power to do that.
Graziella, that brings us to you. It's such an incredible thing that you've been able to restore the vision of some people who've had these issues with the cornea. Can you tell us a little more about that?
Well, yes. We found a way to identify in some part of the human eye a specific area where are localized stem cells of the cornea. It's one part of the body which is avascular, totally avascular, without vessels. So analyzing the ocular surface in several parts of the eye, we found a specific area where are contained the stem cell, powerful cells, able to regenerate this transparent membrane of the humans all over their life. We grow them in culture under specific condition on specific area, and we reconstruct the tissue of the same patient for transplantation.
Josh, tell us, the breakthroughs that are being made in your work.
The main retinal diseases, so-called back-of-the-eye diseases, are neurodegenerative diseases. So they're diseases not of miswiring, but diseases where neurons get sick and die. And that's what happens in Alzheimer's disease, Parkinson's disease, Huntington's disease. And I think as we move on, the progress in neurology and the progress in ophthalmology are going to feed each other, because they're going to be very, very similar mechanisms. They're going to be similar disease targets. And so that's where my hope lies, plus the fact that as new modalities come online, gene therapy, for example, optogenetics, stem cells, things we can talk about as we go on, my guess is a lot of them will be tested first in the retina.
retinal diseases, because we know so much about them and we know how to get into them, may be the test bed for a lot of therapies, which eventually will be used in the rest of the brain.
Well, now, David, this brings us to you. I know that the brain can now control artificial limbs. Can we ever get the brain to control an artificial eye?
Sure, yeah. And I mean, if you look at vision as an engineer would, it's a cascade of modules and operations. So the light has to get through the optics of the eye, and if those are damaged, you lose sight. If the retina, a very sophisticated camera, sorry, Josh, if that's damaged, then the signal doesn't propagate further. But ultimately, where it's going is to the brain. And there are a couple relay stations along the way in the brain that are ultimately responsible for experiencing and understanding what we see. And the more we're able to understand how those circuits work, the more we can we can either interface with those. So you could imagine artificial eyes, bionic eyes, and already you could interface those with the retina, or you can increasingly start to think about interfacing directly with the brain, as long as we understand the language of the brain, as long as we have the technology to do that interfacing. And currently, a lot of the technologies we have aren't ideal for interfacing with the neuronal tissue. So what we end up having to do with current bionic eyes is to actually have quite a bit of computer processing to help you see and sort of meet the brain halfway. So there's quite a bit of video processing that goes into that artificial camera, the artificial eye, that then can interface with the brain to actually give you either the understanding or even a little bit of the experience of seeing.
Let me introduce somebody in the audience. We have Mr. Sandeep Greenberg. Mr. Greenberg has created a $2 million prize for whomever can come the closest to a means of helping restore sight by 2020. And I was going to ask him if he could maybe just take a few minutes to explain his effort to us.
Thank you, Susan. I, too, am honored to be here. Thank you for the opportunity. Sue and I have, in fact, on October 18th, 2012, created a prize, as I said, of $3 million in gold to the person or persons who does most or contributes most to ending blindness by 2020. To be precise, by December 13th, 2020, which is 2,978 days after we began in 2012, the same amount of time it took the United States to reach the moon after President Kennedy announced it. So my reasoning, which may be flawed, is that if we can go to the moon as a civilization, then surely we could end this affliction, which has been with all of us and our bipedal ancestors for more than 6 million years. These conversations began with Professor Schwab in 2008, and that's how we got here. And I have to thank, in particular, Al Somer, Josh Sains, and our friend Stu Eisenstadt for helping us. Thank you.
Well, thank you. That is really inspirational.